Alright, so today we're going to be talking about differential equations. So what are differential equations? Well, we know about normal equations, so maybe we've certainly seen something like x squared minus 5x plus 6 equals 0. And we have certain techniques that we can use to solve this. Right? We have factoring. And that gives us x equals 2 and 3. So this equation gives us a numerical solution. Okay, so a differential equation is just an equation which involves a function instead. So it's best to give an example. Let's say I'm dropping a ball from a building, and we want to know where the ball is at a particular time. Well, we know this follows some sort of physical rule, in particular Newton's second law, which tells us that F equals ma. And this is, in fact, a differential equation for the height, because what is acceleration? This is the second derivative of height, the position. Right? So this equation, stated in another way for this situation, we know the force is mass times the gravity, and the acceleration is the second derivative. Is the second derivative of height. And we can use some various methods. We know our antiderivatives for power rule, so that'll give us the solution. The solution h of t is negative g over 2 t squared plus c1t plus c2. Now, what are these c1 and c2? c1 and c2 here, they're factors of integration, but they depend on the situation. So, for example, if I drop the ball from 100 feet up and I just let it go, do nothing to it, the velocity will be 0 and the height will be 100 at t equals 0. Right, so if I change these numbers here, that'll change what c1 and c2 are. Okay, so let's give another example. Radioactive decay. Right, so there's another observation that we have, is that the rate of decay, dA dt, is proportional to the amount of material that's remaining. And of course, this is another differential equation involving A, the amount of material that we have, and we can solve this, give us ln of A plus C equals negative kT. And again, the C depends on the particular situation. How much material do we start out with? Something like that. So some things we want to note. Our differential equations give us functional solutions. So just like when we had our normal equations, they're giving us numerical solutions, our differential equations are giving us functional solutions. The second thing is that the particular solution depends on an initial value. So really this could be anything that we know about the function, what the values of the functions could be. And these initial values will set a particular solution for the function. Okay, so that's a brief overview of what differential equations are.